Welcome, everybody. Welcome to the Industrial Thermal webinar. We will begin shortly. A few housekeeping items before we get started. Please put your phone and or your computer on mute to eliminate any background noise. Turn on your camera. We would love to see your faces. This webinar is interactive. To ask your questions, you can submit your questions using the chat feature or use the raise hand feature in the participant window. Please wait to be called and then unmute yourself, ask your question, and then remute yourself after you're done. After the webinar, please take our short survey and keep an eye out for a copy of today's presentation. So without further ado, Glenn Koblenz.
Thank you, Mary Dean. And thank you for everybody joining the webinar. It's amazing. We've got over 150 folks on the webinar from all over the world, which is great to see. And this is finally the culmination of a tremendous amount of work from a number of folks at the factory, where we now have our industrial thermal mass flow meter PowerPoint presentation to share with everybody. My name's Glenn Koblenz, Director of Sales for Americas. Been with Sierra since 1999, so tremendous amount of experience, and we are ready to dive in, and we hope that everybody enjoys this. And as Mary Dean said, it's very interactive, so if there's any questions, raise your hand. We've got folks watching the chat box, watching the videos for hands going up to make sure we don't miss anybody. No one makes you smarter. You're going to see this new marketing message coming out from Sierra a lot. This is a layered message. Sierra makes you smarter, and our products make you smarter. We have some of the best in class, if not the best in class meters out there, and that helps you become that much smarter in front of the customer. So watch for this. There's going to be a lot of different plays on how this goes out in terms of the marketing effort. Just as a quick overview of all of our industrial thermal product family, we have our state-of-the-art Quadratherm. We have our good old legacy 640S, 780S. We have our flow switch. We have the 780S, which is the ultra-high purity flow meter used in semiconductor applications for bulk gas metering. And then we have our good old 620S boiler track, our economical light industrial products. Best way to start this off is watching this video. I've used this video for many, many years, probably decades. And it's a great way for those reps that are new, customers that don't quite understand thermal mass flow, to watch this, and it gives you a good overview, and you can use it in front of your customer. Now, throughout the presentation here, I'm going to be moving things back and forth like that, and then we'll be moving the price list back and forth as reference material as we go through the presentation. So let's get back to this one, and let's enjoy this video.
Industrial thermal mass flow meters, also known as thermal dispersion or immersible thermal mass flow meters, comprise a family of instruments for precision measurement of total mass flow rate of a fluid, primarily gases, flowing through closed conduits such as pipes and ducts. The basic physics of thermodispersion mass flow meters is attributed to Louis Vasseur King, who in 1914 published his famous King's Law, mathematically describing heat transfer in flows using a heated wire immersed in a fluid flow to measure the mass velocity at a point in the flow. King called his instrument a hot wire anemometer. However, it wasn't until the 1960s and 70s that innovators like Dr. John George Olin, founder of Sierra Instruments, saw the rapidly growing need in industry for very accurate direct gas mass flow measurement. Dr. Olin pioneered the commercialization of thermal mass flow technology, now widely used in a broad range of industrial process control applications spread across global industries. Applications are as diverse as clean energy, natural gas distribution, flare gas, compressed air in manufacturing facilities, semiconductor manufacturing, wastewater aeration, natural gas to burners and boilers, carbon dioxide for chilling food and fermenting beverages, nitrogen and oxygen in production plants, argon for making iron and steel, and the list goes on and on. Standard accuracy is 1% of full-scale flow, but recent innovation, as with Sierra's Quadratherm thermometer, has pushed accuracy to 0.5% of reading, rivaling that of Coriolis meters. Thermal flow meters are often much more economical than other mass flow meters and have become extremely popular due to high turndown, up to 1,000 to 1, giving the ability to measure very low flows up to very high flows with the same instrument. Since they are rugged and reliable, have no moving parts, are easy to insert via hot tap, have negligible pressure drop, and offer an economical solution to large diameter pipes and ducts, thermal technology has been rapidly adopted over the last decade. So, how does this amazing technology work? In this cutaway view of a typical pipe, the sensor probe is inserted into the center line of the flow. Thermal flow meters have two sensors immersed into the flow stream. One is a temperature sensor, which measures the actual gas temperature inside the pipe as a reference, regardless of the flow velocity. The other is a heated sensor called the velocity sensor, illustrated here in red. As the name implies, thermal dispersion mass flow meters use heat to measure flow. The velocity sensor is heated continuously via electrical wattage so that a predefined temperature differential is always maintained between the two sensors. For example, 50 degrees Celsius is the constant temperature differential for Sierra meters. As soon as the fluid flow begins, heat is drawn from the heated velocity sensor via the gas molecules flowing past. The heat is dispersed as it is carried off by the flow. To really visualize what is going on from a molecule's perspective, let's slow everything down and zoom in. Each gas molecule flowing past the heated velocity sensor has an important job to do. As the gas molecule flows past the sensor, it heats up and carries this heat away with it downstream. The corresponding cooling effect is measured and compensated for instantaneously by the instrument's sensor drive electronics, which instantly add more heating current to the sensor to maintain that constant temperature differential of 50 degrees Celsius. This animation shows that the heat is transferred by the actual gas molecules themselves. In a real-world flow application, all of this happens in a millisecond continuously and never stops. In essence, a thermal flow meter is counting molecules that flow past, heat up, then take this packet of heat away with them and carry it downstream. As a result, extremely sensitive, accurate, and repeatable molecular mass flow measurement occurs. So, now that we know the basic measurement principle, how is total mass flow rate of gas flowing through the pipe actually calculated? The meter's basic output is the electrical wattage carried away by the molecular flow. As the mass flow rate increases, the wattage increases. As described by King's law, it turns out that the heating current required to maintain the constant temperature differential between the two sensors is proportional to the cooling effect caused by the gas molecules flowing by, and therefore is a direct measurement of total gas mass flow rate in the pipe. Now let's take another look at a cutaway view of a pipe with gas flowing through it. We have animated the molecular heat dispersion or cooling effect across the sensor that is occurring. You can see from the meter display on the right, the gas flow is 33.0 standard cubic feet per minute. The yellow dotted line represents the heating current sent to the sensor by the meter electronics. Now, let's increase the gas mass flow velocity 10 times to 330 standard cubic feet per minute. You can see much more heat dispersion. The meter immediately reads a higher flow rate, and much more electrical power is sent to the velocity sensor to maintain the constant temperature differential required. It is important to note that heat transfer from flowing gas is affected by the properties of the gas. These are known gas properties like thermal conductivity, density and viscosity, and heat capacity. All of these must be understood and accounted for when a thermal meter is calibrated to assure best accuracy. For example, at the same mass flow rate, a hydrogen molecule will carry away more heat because it has higher thermal conductivity than, for instance, a nitrogen molecule. The thermometer must account for this difference to be accurate. So, with this in mind, what is the purpose of a flow meter? This is an important question to think about. The purpose of a flow meter is to transfer an accurate calibration to the field. As a result, a flow meter is only as good as its calibration. Thermal mass flow meter manufacturers must assure that the instrument is calibrated on a closed-loop gas calibration system that is traceable to a national standards laboratory, such as NIST for the United States. Sierra Instruments uses a state-of-the-art NIST traceable closed-loop gas calibration system that is charged with the actual gas to be measured and set to the actual temperature and pressure of the end-user application. This perfectly simulates the customer application environment for a quality calibration, assuring the highest possible performance in the field. Be careful of blow-down or open-loop calibrations, as they operate at ambient conditions and are only done on air. As a result, any other application environment will be inferred indirectly, introducing uncertainty, and thus produce a less accurate meter. Be cautious before purchase. It is highly advised to check with your thermometer manufacturer if they calibrate on a NIST traceable closed-loop system. For accurate and repeatable gas mass flow measurement down to the last molecule, choose thermal mass flow technology. Experience our passion for flow. For more
As we said, a very good video. You can share this with your customers. You can use it any way you see fit to sell Sierra flow meters. For those of you that have been around for a long time, when we launched the Quadratherm 640i, 780i, some 10 years ago, never before possible was our marketing message then. And it is still true today. There are still features of the Quadratherm that no other competitor can match or even come close to. One of the number one things of that is the accuracy of the Quadratherm. And I wanted to take a little bit of time here to go through the accuracy statement, because I get this question probably at least once a day about, well, what would be my uncertainty at this calibrated, at this flow rate or this calibrated full scale. So if you see here, you have the two different calibration or the accuracy statements, 0.75% across the whole range. And then below 50% of the calibrated full scale, you add a 0.5% of calibrated full scale. And then over here with the 780i, since we absolutely know the inside diameter of the pipe, it's 0.5%. Now you can use this accuracy statement to determine the uncertainty at any point of a full scale calibration. And that's the key thing that you want to keep in mind. It's the calibrated full scale. So the customer makes that choice. So in terms of a calibrated full scale, we'll go into more detail as we go through the presentation. But the lowest full scale flow rate that you can have on a Quadratherm is 0 to 100. That is because the ultra low flow calibration is back. And we'll explain that further on later in the presentation. And you can go all the way up to 60,000 standard feet per minute. And a good way to see this is if we look here at the full scale flow rates listed for the 640i up to 30,000, 30,000 to 45, and the same thing here. And you can see what the accuracies are here. So anything up to 30,000 standard feet per minute would be this accuracy statement. Now, as I mentioned before, the minimum full scale that you can go to is 0 to 100. But any flow rates that the calibrated full scale 0 to 100 up to 0 to 499 is considered a ULF calibration, and there is an adder for that ULF calibration. You would find that in the actual price list right here. If you go down to the bottom, you will see the ULF definition. Full scale calibrations 0 to 100 up to 0 to 499. Now, with this statement here, let's figure out some accuracy. So if we have a 640i with an 8-inch pipe calibrated at 0 to 100,000 standard cubic feet per hour, what is the accuracy at 60,000 standard cubic feet per hour? Use the accuracy statement, previous slide, to determine the accuracy. So everybody go ahead and try to figure that out. We're going to be looking at the chat box to see who the winner is. I want the right number in there, and I want the right unit of measure. So we're starting to see answers show up, and there we have a winner. Nicely done. It's plus or minus 450 standard cubic feet per hour. Now, those of you that are still wondering, well, how in the world did we come up with that? Here is the math. 100,000 standard cubic feet per hour divided by 60 gives you SCFM, divided by the area of the pipe. Gives you your standard feet per minute. So the standard accuracy is that. So it's 450 standard cubic feet per hour because it's above the 50% of the calibrated full scale. All right, let's do this one more time so we get familiar. 640i, 8-inch pipe, 100,000 standard cubic feet per hour. What is the accuracy at 1,000 standard cubic feet per hour? Again, I'm looking for the answer in the chat room. This was a little bit more involved because this may or may not be below or above 50% of the calibrated full scale. Should be clear looking at it that it's below 50% of the calibrated full scale. And now we have an answer. Very well done. The answer is plus or minus 507.5. So let's see how we did the math on that. Again, we're taking the 100,000, we're figuring out where we're at by the area. Oops, I'm on the wrong one. 100,000 divided by 60 SCFM, we get the standard feet per minute. Okay, but if we look, we're dealing with 100,000 standard cubic feet per hour. So it's 0.75% of reading equals this, but since it's below 50% of the calibrated full scale, you're adding a 0.5% of full scale, which is this. So that ends up being your total answer. All right. And again, you can use that accuracy statement to determine the uncertainty at any point between 0 and the calibrated full scale. So key growth, if we look back over the last 10 years of the Quadratherm, what has really driven those sales? Well, one, it's the highest accuracy flow meter. It still is out there. Its field flexibility and field configuration is still unmatched by any other competitor out there. And all of this can be accessed through the SIP program, which a majority of you have probably already hooked up to one of these meters and you know exactly what we're talking about. But we'll show snippets of the SIP as we go through the presentation. And QMix. QMix is a feature that no one else can do. And it's an ever expanding feature to the Quadratherm as we add more and more gases, more and more capability via QMix. And we'll get into that more in depth as we go through. The whole success of the Quadratherm rests on those sensors that you see. You have the dry sense velocity sensor, which is the sensor with no organics in it, lifetime warranty on that sensor. You have a 4-sensor design in terms of temperature, and you have the iTherm brain that does all of the calculations for you. Here's a close-up picture of it. This is the actual velocity sensor. This is a standoff sensor to keep you from breaking the sensors as you install them into the field, and this is just measuring what the ambient temperature is. Okay, looking at a little closely at this, more closely at the sensor of the dry sensor design, everybody else's sensor that's out there has an organic between the RTD and the stainless steel sheath. And if you're constantly heating and cooling this, you're creating gaps, air pockets, and that is causing drift in a thermal mass flow meter. Everybody has it. But if you look at a Sierra design in a Quadratherm, and also the same sensor is used in the 640S and the 780S, there's no organics in here, so there's nothing to break down. So in theory, it should not drift. And over the last 10 years, actually more than that, because being introduced in this 640S and 7080S, it does not drift over time. And we back it up with a lifetime warranty on the sensor. There's a great video. We're not going to watch it here today, but you can share this with your customers and everybody on your team. It's a great video that goes into depth of why ours is so much different than everybody else's. But since we have that sensor, we can offer the sensor warranty. So it's a lifetime warranty on the sensor for free replacement and recalibration if the sensor fails in the life of the product. And actually, since we have released this product, we have not had a sensor fail because the sensor itself failed, because it broke down. The organics broke down. There is no organics, of course, but because of the sensor breaking down. Now, we've had plenty of sensors broken, electronics filled with water, probes filled with water. That's not covered with the sensor warranty, but the actual sensor itself breaking down and eventually failing, we have not had happen. But that will happen in a number of other, in all other competitor thermal mass flow meters. It's only a matter of, it's not if, it's when. Only takes time before that sensor eventually breaks down and will eventually fail. We talked about the temperature. In a traditional thermal mass flow meter, you have two temperature sensors. You have one on the velocity sensor, you have one just measuring the ambient temperature. But the velocity sensor is what's being heated up. So all this heat is going up here and heating up the probe. We call that false flow. Everybody else has that problem. And that's why the accuracies are not where they're at, or where they can't match the Quadratherm. But if you look at the Quadratherm, we have 4 temperature sensors. So on the velocity sensors, you have one here, here, and then over here. So what we're looking for is heat transfer into the probe. You need to keep track of that. And the Quadratherm keeps track of that. That information goes up to the brain. That's considered false flow. So that is taken out of the equation so that it does not end up being false flow on the reading. We talk about the Q-Therm brain. This is what takes care of all of these variables. So it's basically running on the first law of thermodynamics, and it's solving that equation. So there's all different types of inputs that go into this equation that the meter is describing the flow inside of the pipe. It takes all this information in, and it's going to calculate what your mass flow reading is. Now, everybody else's thermal mass flow meters, including our legacy products, based on a Wheatstone bridge. So it's one application, one calibration, maybe a little bit of hocus pocus here and there where you can make some changes, but it's very, very limited. And if you do make changes, you start to lose accuracy fairly dramatically. But the Q-Therm brain keeps track of all of this stuff and is delivering the most accurate mass flow measurement that you can get. Again, just as a review here, the Q-Therm brain and combined with the sensors, we're keeping track of everything. The stem conduction, that's the heat going up the stem. What gas is it measuring? Are the temperatures changing? Are the pressures changing? Now, thermal mass flow is a direct mass flow measurement. So the only thing that's happening with changes in temperatures and pressures are the molecules are moving closer together or further apart. So that's affecting that heat transfer. But we keep track of this anyway, because if you get to various different extremes, we need to know that and need to make adjustments in that calculation. I've always liked this picture. This is from early on. This is probably from 12 to 13 years ago when we were first doing all the original research on this. This is showing the 2 sensors and what happens with the heat as it goes by, or actually the velocity, but you can think about that in terms of heat, is this is what you want it to look like. This is perfectly conditioned flow, bullet nose flows hitting these sensors. And this allows for the efficient transfer of heat from the heat on the sensor to the molecules going past it. That's what you want to see. And the reason why I bring this up is if you do not have conditioned flow or you do not have a 780i, it doesn't look anywhere close to this. And then you start to lose your accuracy, you start to lose your field flexibility and everything. So I've always liked to show that. That's what it looks like inside of the pipe in terms of the velocity as it's going past the sensor. Okay, it all culminates into the most accurate thermal mass flow meter in the world, and it's been that way for the last 10 plus years. I'm also going to share with you some graphs that were generated about a decade ago. And the thing I want you to take away from this is this purple line is what the Q-therm brain thinks the flow should be based on that we've told it that it's air, that it's this pressure range, this temperature range. It will calculate at some mass flow rate, this is the amount of heat that should be taken away. And then we put it on the flow loop and actually take data. And you can see that the data actually fits perfectly with what the predicted flow rate should be. So this is very important because on the air calibration that is in every single quadrotherm, that's the basis for all the other Q-therm calibrations and Q mixes. So you want to make sure that the brain is predicting things correctly. Now let's move to methane. Again, the purple line is what the brain, Q-therm brain, thinks the flow rate should be at these various different heat loss conditions. We put it on there and we actually see what the actual data is. It lines up perfectly. Do the same thing for carbon dioxide, a much harder gas to approximate. You can see what the Q-therm thinks it should be and what the real data is right there. And argon, again, another hard gas to do this with. Again, the Q-therm brain is right on the money, and you see the data points coming down. So the whole upshot of this is when you're switching gases and using that field flexibility, you're getting some tremendous accuracy in the field. All of this can be unlocked in the field by going through the SIP. And within the SIP, and also you can access all this information through the display and the push buttons, but I always like to connect via the SIP, is all of these things now start to open up as field flexibility, things you can change. Gases, T and P, temperature, it's just keeping track of everything. And the SIP allows you to look at all those different things you can change in the field, you can change. One of the big things within the Smart Interface program is this Q-mix gas composition. So if you see over here, every single gas under the sun is in this chart. And you can use these gases to put over here to create a pure gas or a gas mixture. It can then sit in your gases database and you can upload it to the meter anytime you want. So Q-mix can be ordered from the meter originally, or if it's out in the field, you can always order it after the fact. It just takes a credit card and calling up our service department, and they will create a code for you based on the serial number of this particular meter. It'll ask you for that code when you first hit Q-mix if it's not already activated, and you'll have full activation. Now, one of the advancements that we've had with Q-mix, taking it up to the next level, is Q-mix real-time flare management system. This is where you can combine a 640i with Q-mix with a gas analyzer hooking to a laptop, but this ends up being an industrial laptop in the field, or industrial PLC, where this is running constantly, and you can upload new gas compositions into the meter as often as once a minute if you want to. All of these facilities have multipath ultrasonics, but what they found out is to meet the regulations, the multipath ultrasonic is not going to work. Multipath ultrasonic can't measure the zero flow and it can't measure 100% hydrogen. Well, it's two things that the Q-Therm, Quadratherm can do really well. So us and the engineering team started working with some refineries on trying to come up with a solution, and kind of the holy grail of a thermal mass flow meter of just sending it a new composition anytime you want and having the meter make that measurement. That day has now arrived. We've got 5 or 7 of these full systems up and running, working in the United States. Okay, and they're all being used in conjunction with multipath ultrasonics, because those things are expensive and the refineries aren't just tossing them out. Okay, but when you're looking at this system, you basically have a device that is on site, all right, that creates via Modbus whatever the composition is. We need to know the percentage composition. That comes through the digital communications, goes into custom QMix software that's developed and written for each unique application. And then that is connected to the 640i, and then it can be updated as often as every 30 seconds. The new composition can be put into the meter. Now, my hat's off to the engineering team, Cam and Brian and the whole crew there. The advancements that we've made to the brain and what happens inside of here are downright amazing. We've put in what's called a 40-point calibration, which is basically your 0.75% of reading from 0 all the way up to full scale. So there's no more percent of full scale. Now, of course, as you approach 0 flow, your uncertainty eventually goes to 100%. But we're talking with flow rates as low as 0.1 standard feet per second and screaming flow rates up to 120 standard feet per minute. And what some of our customers are realizing is, hey, this can handle everything. I don't need the multipath ultrasonic. This will handle it all. Right now, we're just really focusing on this, letting the multipath ultrasonic handle everything else. You've got an easy to install meter, okay? Typically what you're gonna have here is either a 300 or 600 pound flange. I understand the flare gas is atmospheric, but there are piping codes on refineries where any flange has to be a certain rating, but you work up whatever you need here, and they're all hot tapped. Well, they'll be put into the pipe, you get huge turn down. Now let's watch this video. This video is brand new, and we are hitting a marketing blitz with this across all of our contacts in the refinery and chemical.
For more than 45 years, Sierra has pioneered the development of precision thermal dispersion mass flow meter technology. Today, we are proud to introduce Sierra's breakthrough Quadratherm QMix real-time flare measurement system, FMS. For the first time, oil and gas engineers have an alternative to ultrasonic flow meters to meet the ultra-low end of EPA's Refinery Rule 40 CFR 63, which requires accurate flow measurement down to 0.1 feet per second. Traditionally, ultrasonic flow meters have been the meter of choice to meet these strict flare gas regulations. But now, with the new low-end requirement, ultrasonic meters have the following limitations. The large installed base has been calibrated to 1 foot per second, so they can't meet the low end of the regulation. Measuring low velocity is difficult due to a small delta T. Flow turbulence reduces signal strength, and typical flare gases like CO2 and H2 attenuate the signal, so it's difficult to read low flows. Sierra's QMix Real-Time FMS meets these application challenges. Unlike other thermal mass flow meters where flare gas composition must be manually adjusted and uploaded, QMix Real-Time FMS connects to your installed gas analyzer to deliver continuous, real-time flare measurement down to 0.1 feet per second. When the gas composition changes, the QMix Real-Time app loaded onto the supplied laptop reads the outputs from the gas analyzer for an updated flare gas composition. In real time, the app creates a new gas composition and automatically updates the 640i thermal mass flow meter. The meter now accurately measures the new flare gas composition and measures flow down to 0.1 feet per second and maintains accuracy even with changing gas composition in real time. It handles upset conditions at ultra-high flows with wide 1,000 to 1 turndown and measures very low-pressure gas with variable temperatures with no pressure loss. Get your compliance work done in the fastest, most economical way with Sierra's QMix Real-Time Flare Measurement System. Our team of engineers offer custom configurations, on-site commissioning, and engineering support over the lifetime of the system. We understand flow is tough. We can solve this together.
So if you have refineries, chemical plants in your area, that's a video that you want to get in the environmental people's hands. Your contacts there. This regulation has been on the books for a while, but the political climate has changed here recently, and these things are no longer getting swept under the carpet. And they are going to have to start reporting this. And I don't care what state these refineries are in, it's eventually going to get to them. And sometimes the fines for not coming in your permit or not measuring correctly or reporting correctly can be upwards of $1 million a week. So the price of this, and this is a turnkey installation, you notice it's not on the price list. This is a discussion that if you have these type of applications or this kind of opportunity, this is not just a flow meter. And a lot of the ones that I've been involved with, the customer thought this was really cool, but they really didn't need it. They just needed a flow meter. But when you're dealing with main flares at refineries, main flares at chemical plants, this is something that is going to be needed to supplement the multipath ultrasonic, or we even have a couple discussions going on right now where they're looking at this as the main flow measurement for the main flare. So just to give you an idea where we are price point wise is, depending on the final configuration of the 640S, plan on about $50,000 per point. And that includes the engineering team coming out and making sure that everything works at startup. So there's a lot of hand holding going on right when these go into the pipe, get all wired up, you start the flare up, and then away you go. So powerful, powerful technology. It's not for everybody, but if you do have refineries in your area, it's probably going to be worth your time to figure out who the environmental manager is. They all have them now, and that person is directly responsible for not getting fined. And they're going to be very interested in this, and then it'll open itself up of operations managers and things like that. But that's a great way to get started. In all of the ones that we put in, the environmental manager or the facilities quality manager, they were front and center in all these discussions.
Glenn, before you, Robert
Yes.
has a question. He's asking, why are we calling it flare management system if it can be used for natural gas and all kinds of gas mix measurement?
That good question. Typically, we call it flare management system because we're targeting main refinery flares, main chemical plant flares that already have $200,000 multipath ultrasonics in there. So, you know, if you've got somebody that wants to measure it for natural gas and thinks it's the coolest thing since sliced bread, you know, if it's just natural gas going to a boiler, they're not going to drop 50,000 on something like that. Maybe they do. If they do, you're going to get salesperson of the year. That would be incredible. But it's focused for a market and an opportunity that is about to get fined very, very heavily, and price will not be a problem. Now, we also have folks, you know, from North Dakota down to Texas that are looking at this in their midstream stations. So if you have a lot of batteries that are coming together, a lot of different oil coming in, a lot of natural gas coming in from a lot of different customers, you've got these main locations that are gathering all this up, and they have a main flare. They're possibly looking at that right now. Most of them have 640Is in them, and they go out and manually update the composition via QMix when they need to. But some of them like the idea of the automated update, and they do have mass specs or GCs on site where they're getting the composition of the gas going to the flare. So, but again, good question. And if you can sell it into that market, that is, you know, sell it in markets other than what it's intended for, that would be wonderful. Here's all the different various digital communications that we call out. That we have a much bigger chart later in the presentation that we'll cover. But as we talk about the Quadratherm, there's some key product differentiators and specifications I want to make sure that everybody understands. We've covered the accuracy. Okay. We've covered calibrated full scales up to 30,000 standard feet per minute on any gas or gas mixture. And if you remember, we found that in the price list and the accuracy statements at the back. Here is some powerful information. All these different gas tables. There you can see the accuracy statements for both products of what the standard feet per minute is, and that. Remember, standard feet per minute times the area of the pipe is giving you standard cubic feet per minute. And we'll have a little something later to work on that. So calibrated full scales up to 60,000 standard feet per minute with a slight D rate of accuracy, and that was on that price list. Here's something I want everybody to really understand. Calibrated full scale may be increased to 2x. Okay, this used to be infinity. And then we moved it down to 4x, and then we moved it to 3x, and then we moved it to 2x. We were kind of getting a little carried away there with Quadratherm of basically its calibration went out to infinity, but the inaccuracy that you could get was a mixed bag. Maybe it was plus or minus 100%, maybe it was plus or minus 5%. So we dialed it back down to something that was a little bit more predictable. So what I mean by this is, let's say you have a customer that has a compressed air line, they get the meter out there, they put it in the line, and it's calibrated 0 to 1,000 SCFM. Okay, and let's say the equivalent standard feet per minute of that is 10,000 standard feet per minute. An engineer made a mistake somewhere, okay? They really need 2,000 SCFM, not a problem. You can go into the full scale and you can up it to 2,000 SCFM. Now, is your accuracy still going to be 0.75% of reading and 0.5% below 50%? Probably not. It's probably going to be 1 to 2% of full scale, but you just save the day for it. They don't have to send it back. They don't have to get it recalibrated, because that was a pretty horrible mistake to miss the full scale calibration by 100%. So that gives you a 2x in the field. But again, remember, every order that gets sent in, we need a complete and correct ADS sheet. And to calibrate, or even to quote the meter, you probably have this information, or at least you know this information. You're definitely going to need to know it to send the order in so John and Fred can check it. And if it's not complete, it's not correct, you're going to be getting it back. But at least in an instance like this, you get it out to the field, a mistake made it all the way through, you get this 2x capability. I end up using this a ton in the oil and gas because they'll order something 5 million standard cubic feet per day, and the flare is 150 foot tall and the meter is railed out. Well, sometimes the 2X can handle it. Sometimes it doesn't. And in those cases, it does have to come back. ULF calibrations are back, okay? From 0 to 100, and then available from 0 to 499 standard feet per minute. Be careful with this because the minimum ULF calibration is 0 to 100 standard feet per minute. Okay, so anything between 100 and 499 can be your full scale, and that is an incredibly, incredibly low flow rate. You go through the math on that, you're talking single digits of SCFM. So very, very flow rates, and this can be done for 640i or 780i. And then when the order gets sent in, if you have a full scale on there that actually is a ULF calibration, John or Fred will send it back to you going, well, your full scale flow rate's equivalent of 350 standard feet per minute. Would you like to add the ULF, or would you like to add up to round up to 500 standard feet per minute so you don't have to pay that adder? So we'll give you that option to do that. Even if you round up to 500, remember the accuracy statement still applies. You're still going to be measured all the way down to 0. Okay, it's multivariable. You get the mass flow rate, you get the temperature and pressure, the 4-sensor design, you're getting the no drift sensor and the lifetime warranty. Talked about the brain is just keeping track of everything. You can change your pipe size. You can change your gas through the QMix functionality. Again, here you can change gas composition in the field, retain accuracy. So any gas you want to put in the meter, any gas mixture you can put in the meter. Since it does have the all metal sensor, it's not going to move. You can use the Valid Cal Diagnostics from the SIP program to verify that performance. Everybody should be familiar with the Smart Interface program. If you sell one of these meters into the field and you have a chance to be in front of the customer, and go in there with pride. You just sold them the best possible product on the earth. Show it off. Show it off with the Smart Interface program. Show them everything that it can do. Even though they might not be interested in any of that, that'll stick in their mind going, hey, I might want to have this as a spare. You know, I might want to have this as a spare for my carbon dioxide line, my argon line, my helium line. I don't want to put a meter in every one of them, but every once in a while, I might want to check the flow. This one meter can do it all. And we talked about the digital communications it comes with.
All right, Glenn, you got time for a couple questions?
Sure.
All right, first question is, when will we have a PED certified body for the 780i? I'm not familiar with PED, so.
That question, let's have that question go through Moritz Cope, who's our manager for Europe. Him and Scott Rouse would be leading up that charge of where we're at on PED and when that might happen.
Okay. Next question is, can you clarify on the ultrasonic meters currently used for the real-time measurement on flare applications? Do they need gas composition? Are they as sensitive to what the gas composition is as compared to the 640i?
So on your multipath ultrasonics on your refineries, they have pressure and temperature compensation and density composition compensation. So there is a ton of stuff going on behind the scenes to make those read mass flow in the same way that a 640i would read mass flow. So yes, the composition of the gas and the changes of that ultrasonic, multipath ultrasonic flow meter eventually gets that information. The base measurement of multipath ultrasonic is purely volumetric. That's all it knows. Volume. I have a cubic foot. Then once you have a cubic foot, then you put pressure, temperature, composition on top of that to get to mass flow. So yes, they're eventually getting to the same answer. They get there just a little bit differently.
Okay. Next one, can you clarify the ULF ranges? 0 to 499 question mark. I thought it was 100 to 500.
Yeah, that was that in the, let's go back to the price list. Great question. Let's refer to the price list. We spend a ton of time on this document, all of us do, to make sure that it's 100% correct, but sometimes it isn't. But if you look down at the definition, which should be corrected now, here we go. Full scale calibrations from 100 standard feet per minute to 499. So what this means is any calibration that you have where the full scale falls between 100 standard feet per minute and 499 is considered a ULF calibration. So it's 0 to 100. That is the absolute minimum full scale, or 0 to 499. Now, if you get to 0 to 500 standard feet per minute, well, guess what? You don't have to pay 585. Now you're dealing with just a regular calibration up here, okay? So 0 to 100, or 0 to 499, or any number in between, multiply by the area of the pipe in square feet to get SCFM, and then you can convert that to whatever you want. Standard cubic feet per hour, pounds, kilograms, grams, etc. Okay. All right, let's take a look at the website. And guess what? There's our web store. So in these current days where it's a challenge to get things fast from Sierra, and we've got a whole team working on making that experience a heck of a lot better, and it's happening soon. We are showing improvement. But if you want something fast and the customer is a little bit flexible, go to the web store. All of our products are there. Guess what? Here's the Q-Therm, okay? What have we been talking about? 100% field configurability. You can change it to almost anything you want. So if somebody's screaming for one in 5 days or 10 days, there might be one on the website that would fill the bill for them, okay? We've got all of our other products on there as well. So a good place to look for something that somebody wants it fast. You know, they're checking with all the competitors. Our standard lead times are unacceptable at this moment in time. There might be something in here that just works for you, and it will work for the customer. But remember, these are all pre-calibrated. So some of these are going to be inflexible, like a 100. If it's 10 standard liters per minute, it's 10 standard liters per minute. But if the customer wants to measure 7, well, guess what? It still works. They just have a little bit more on the high side there. Okay. All right, we've spent a lot of time talking about the Q-Therm. It's been out for 10 years. It's still the leader in the marketplace. And there are many, many customers out there that like the idea of having the best possible product out there. Price is really not that important. They want the best possible performance. But then, you know, you've got your crew that wants the lowest price thing on the market. And, you know, those folks' money spent just the same way as those that want the best. So we have all of our other industrial thermal mass flow meters. We have our legacy 640S, 780S, ultra high purity 780S. This is what you'll find in semiconductor plants, bulk gas semiconductor plant. A lot of that, unfortunately, has moved to the Far East, but there still are opportunities in certain parts of the United States to sell these meters. And we have our light industrial meters, 620S, for any non-combustible gas, air, carbon dioxide, argon. And then our 620 SBT, which is just this with limited power for methane and propane measurement. We also have flow switches for liquid and gas detection. flow or no flow. So all the benefits that we share, they're all direct mass flow measurement. No T&P compensation, we talked about that. You're eliminating drift with that DrySense technology. Nobody else has that. Every other competitive product out there is going to drift like a boat in the ocean. And they'll have all kinds of fancy things to reset zero, to do this, that, and the other thing in the field. But keep in mind, it's still drifting. And that drift accelerates as its age increases. We back up that DrySense with a lifetime sensor warranty. No moving parts. It's not like a turbine meter that you're going to blow apart every time the gas flow changes too aggressively. We can measure gases and gas mixtures. Super wide turn down, but remember, that's a marketing gimmick. When you get into that discussion, you go to the absolute accuracy statement and calculate the uncertainty at any point across the full scale that the customer might be thinking about. So they will know, okay, if I do a full scale to 1,000, if I'm measuring 10, which I can, my error is plus or minus 10. So it's 100% uncertainty. That's not good enough. Well, then we're going to have to move that full scale down. So you can use that math to help the customer understand exactly what they're going to be getting in terms of uncertainty. Low flow sensitivity, and this goes not only for positive pressure, but vacuum flows as well. So even in a vacuum, the molecules haven't disappeared. They're still there. They're just a long way apart, but they're still moving down the pipe and they're going to bump into the sensor. So in vacuum situations, you're just going to have very, very low flow because you just don't have that many molecules around. Very, very low flow. Low installation costs, especially in big pipes. You can go with the insertion and you can do the in situ calibration validation. We'll talk more about that a little bit later. We mentioned this earlier. All of our legacy products have that 2-sensor design, 2 RTDs in there, Wheatstone bridge. So what you sacrifice with this is accuracy and field flexibility. But we still have, I was going to say tens of thousands, but we have over 100,000 of these in the field. Just as a reminder here, we talked about it a little bit earlier, but the straight run of pipe is critical to flow measurement. So don't shortchange that, especially if someone's going to pay $6,000 for a 640i with all the bells and whistles, and they install it 1 diameter downstream of a double 90 out of plane. They're not going to get the result they were hoping for. So this is in every installation manual that we have that you can find on our website. Please discuss this with the customer. Put in the proper straight run of pipe. If you're going to pay that kind of money to make that kind of precision measurement, make sure the pipe is prepared for that.
Glenn,
Yes.
a couple quick questions.
Mm-hmm.
First, got a question about the USB on the 640i, 780i. When is that going to be going live? And we can move away from the RS-232.
Great question. So for those of you that have worked with the 241i and the 241i and 240i in the field, that's our mass vortex meter. If you've done that, you've noticed that the USB on there works. Plug it into the laptop with the USB. I always recommend that you get a separate isolation protector because sometimes the customers don't quite have electrical wiring down and there's a lot of voltage that sits on that meter. And guess what? As soon as you plug in a USB to a USB laptop with no protection, all that voltage goes to your laptop and guess what? Pop. Laptop no longer works. So hold on just a second. Let me see here. Sorry folks, I thought I had mine handy, but any kind of US surge protection will work. And if you're not quite sure what to look at, Rory Ross will be able to give you all kinds of options on things that he has found that work very, very well for these isolators to put in there. 640i, 780i. So that is based on Raptor. By the end of this year, it should be out as Raptor 2 as the operating system, and the Raptor 2 operating system will support the USB connection. So it'll be just like the 240i and the 241i connection, USB to USB right into the laptop. But please use an isolator between those if you do not trust the customer's electrical wiring ability. I don't take any chances on that. So it's cheap insurance.
Second question is regarding custody transfer on any of our devices. Are they rated for that, specifically the 780S?
None of our meters are rated. Are we talking custody transfer of natural gas?
The question does not specify, but I would assume natural gas.
Okay. So custody transfer of natural gas has to be an AGA approved meter. None of our meters are AGA approved. AGA approves a technology, not a manufacturer. So it would be up to Sierra to cover that entire bill of that, and we're just not in a position to do that at this point in time. But it's something they're always looking at because we've got the best meter out there in terms of accuracy, and it far exceeds what the AGA requires. It's just you got to pay all the money to get the AGA stamp. We're not there yet. All right, 780S. I'm not going to go over every single one of these, but I'm going to point out a couple things here. Flow range up to 20,000 standard feet per minute. The thing that you want to keep in mind with the legacy products is that it's not the Quadratherm, and every gas has a different full scale. So let's look at the 640i table and the gas table. That's why these are in the price book. This is air, maximum is 20,000. This is argon, 28,000. CO2, 19.8. Digester gas, 17.2. So the whole point of this is, depending on what gas you're using, the full scale flow rate will be different for our legacy products. So you need to keep that in mind when you're sizing those up. And we'll cover this a little bit more in detail a little bit later. But that's another thing. And that's what makes that's why it makes such an all-encompassing sizing program so incredibly difficult. The math behind coming up with something like that is mind-boggling because of all the different overlap, all the different capabilities. It's not to say that we're not trying to do it. It's just a Herculean task of coming up with a sizing program that emulates the experience that we all have about how to size these, and then go into this customer of saying, well, guess what? Every single one of our products will work for you, but there's one that's going to be the best. And that comes from experience. That comes from your experience and being able to transfer that to the customer. We make flow plates. So these are separate flow plates. And the reason why we put this behind the 780S is they're built into the flow body. The leading plate is here. The lagging plate is here. Pointer flow is going this direction. So there's flow plates built into there, okay? But we also build flow plates as a separate device. And you can see this leading plate is a little bigger than the lagging plate. The lagging plate is the diameter of the pipe that it's going into. This one's a little bit bigger so that you can squeeze this between flanges or just kind of tack weld it into place. We go back to the price list. You can see all of our flow conditioners are right here. And you can see all the sizes that we make. And we can make any other size on there that you don't see. That would just be an RFQ. And we've made them up. I think the largest ones that we've done are 66-inch flow plates. Those were massive, and they were upstream of just a simple 640S, gave them a good measurement. Now, the reason why you might want to consider these very large flow conditioning plates is every once in a while, you will get into a battle with a multi-point system from FCI, from Kerrs, or other folks where they're saying, hey, guess what? We'll do a multi-point system for your 6-foot duct here, and you'll be in good shape. Those are incredibly expensive. And if you think about how a multi-point works, it's a pipe and one probe that goes across the pipe. Maybe there's 2 probes that go across the pipe. Now you're doubling the cost. But what happens with the flow here and here? It's not being measured, okay? So they're missing a lot of spots, and especially if they don't have the straight run of pipe, a multi-point is basically useless in terms of making an accurate measurement. A nice alternative to this is say, hey, on your 30-inch pipe, why don't you put a $5,500 flow plate in, tack weld it into place so you don't have to buy a 30-inch flange, and put a 640i downstream of it, 1 diameter downstream of it. We're giving you standard accuracy. It's a make your own 780i in a 30-inch pipe. You can plumb a 90 right into that. So your 5,500 here, let's call it 6,000 for the 640i, your 11, your $12,000 max. A 4-point multi-point from Kerrs or FCI, you're pushing $25,000. So you're half price already, and you're giving them an accurate measurement. So anytime you see those multi-point specs, man, I go after them aggressively, because if you, sometimes you can get the customer to understand that, you know, they're being sold technology that's past its time. We can make these flow conditioning plates big, and you can turn it into a single point measurement. And we've had success doing that at a couple different locations that were basically hard spec the FCI multi-point, and we converted them to our solution. 640S, been around a long time. Again, call out different flow rates, different accuracies here. 780S UHP, again, watch those flow rates, watch those maximum flow rates per gas. They're all in that gas table in the price list. Different accuracy. And again, these are going to be for semiconductor applications. This has an RA finish on the inside of anywhere from 5 to 10. Okay, a lot of this business is left the United States, but some of it might be coming back. There's a lot of incentives to that are going to be thrown out there in the next year or two to have homegrown semiconductors again, instead of having others in other parts of the world control our destiny on these type of chips. So if semiconductor plants come back, guess what? A ton of these come back, because a plant is filled with these. So just to give you an example, there is a Micron facility in Utah that probably has $500,000 of these installed. They use them everywhere. So for those of you that are fortunate to have semiconductor plants in your backyard and you haven't sold them UHP meters, I'd be knocking on that door. Light industrial thermal. These are economical flow meters, and they have ceramic sensors. So these do not have the lifetime sensor warranty. These will eventually drift over time and will have to come back. Okay, it's the same exact product, except this one can be powered by 24 VDC. This one needs to be powered by 15 to 18 VDC, because you're dealing with explosive gases here. Here's the ceramic sensor. Okay, it's kind of a stacked RTDs, but one of the things is it's very fast, incredibly faster than our legacy products and the Quadratherm. So if somebody that needs to make a very fast measurement, this is a great way to go. You can use this all the way down to a 1-inch pipe We have had some people put it in a 3/4 inch T, and it's worked well there. It's worked there as well. This is not fragile, it's not delicate. I've had a 640S or 620S demo for 15 years. I don't know how many different flights it's been on, how many different customers it's on. The outside looks pretty rough, but it is never broken. So if you take a little bit of care during installation, it's going to last a long, long time. But don't be scared away by, you know, a full industrial application. These can be put outside as well. You see 24 VDC. You can see the pressures and the temperatures up to. That's called out on the price list and the gas sheet there. This is optimized for natural gas and boilers. This is probably our biggest selling product in terms of numbers of units. It's such a simple product to put in a natural gas line or a propane line. A very, very economical choice, and it's given a customer direct mass flow. Also keep in mind, you can hot tap these. A lot of folks don't realize you can hot tap the 620S and the 620S boiler track. I'll show you how you do that. Okay, so again, we see our good old price list, the base, probe length, remember center line of the pipe, process connection. And I want to call your attention to the M6. This is a Connex packing gland. So this allows you to hot tap the 620S or 620S boiler track. We do not include the ball valve with this. All right, so customer will have to include the ball valve. And then away we go. I've got a particular customer that has about 45 ball valves installed and one 620S boiler track. They just move it from point to point to point to point. They're just constantly checking flow and optimizing burners that are part of ovens that happen to be baking potato chips. They want to make sure that it's perfect. They don't want to spend the money to have a boiler track on every one, but they do want to have the ability to go out and check things when your potato chip is burnt off of the conveyor or not cooked at all. So that's a quick and easy way for them to check, well, that's not the problem. We've got plenty of natural gas. There's some other problem. But since we're here, we'll just look at the gas codes here. Again, one gas. Here are your non-combustible gases for the 620S. Here are your combustible gases for the boiler track and their accuracies. And remember, calibration's up to 120,000 standard feet per minute. And anytime you have a question about, well, what can I calibrate to? Always go to the gas table. You can see all the different full-scale calibrations of what they can be calibrated to. Okay.
Glenn, we've got a quick question. If we could go back to the 780S, 640S, just briefly, do we have a timeline on its life cycle? Are there any plans to retire these units in the future?
There are no plans to retire the 780S or the 640S. Keep selling them. They're going to be around for a long time.
Thank you.
Okay, as we did before, we're just highlighting that the 620S and 620S boiler track can be found on the website. They're pre-calibrated 1, 2, 3, 4 inch, 1, 2, 3, 4 inch. Well, what if a customer is in a big hurry and they've got a 6-inch pipe and they need it in 5 days? Well, our standard lead time, you're never going to get it. But you could, if the customer has flexibility, you sell them one calibrated to a 4-inch pipe and you use a K-factor capability from 0.5 to 5 to resize the area of the pipe that meter thinks it's measuring to give them a ballpark measurement. So as long as you have a customer that's a little flexible with what their expectation is in accuracy, there's a couple ways that you can solve the problem at that point in time. So again, you're adding in a fairly large D rate by going from 4 to 6 inches, but at least he's making a measurement. And maybe that's good enough for him at that point in time, based on the other things that he's having to deal with. Here's that chart that I talked about that has all the different digital communications and all the different products and what is required. And as you find, everything requires P2, 24 VDC. So when you're dealing with an AC meter and they want a digital communication, unfortunately, that's not us. So hopefully you can talk them into having a 24 VDC powered meter versus staying with the AC powered meter. All right, well, how do we accomplish all this stuff, especially with the 640i? Our current flow loop could not handle the accuracy required when you do metrology rules of 4 to 1. So we spent a lot of money and built this new flow loop there in Monterey. Some of you have seen it. It's up and running, and it's mainly calibrating all of the quadrotherms to deliver that high-end accuracy. So we did, and again, we talked about it, it is a closed loop calibration. Throughout the whole presentation here, we've talked about the DrySense, the no drift sensor, the lifetime warranty. And this video is also on our website. We're gonna watch this video as well. For one reason, I need to give my voice just a little break. But there's some powerful things in here because a lot of the competitors will call out ways to calibrate their meter in the field. Well, no one is calibrating a thermal mass flow meter in the field because you need a primary standard to do it. And you're not putting a primary standard in a customer's line to calibrate it, okay? So all of these things are validations in the field. Now, everybody else's meters drift. So the way they do these validations sometimes can be hocus pocus, you know, shifting the zero, all these type of things. But the way we do it is quite unique because we're telling you it's not drifting in the first place. So if you get into discussions with customers about this, this is a great meter to show them, especially if they're comparing it to competitive products as well. Let me start this.
Truly industrial strength. Dr. Olin pioneered the innovation of an all-metal clad thermal sensor in the early 1980s. Wet thermal sensor design, because of the organic potting cement used, would shift and crack over time, causing unwanted sensor drift, resulting in a gradual degradation of flow measurement accuracy. Today, wet thermal sensors are used by all industrial thermal sensor manufacturers on the market, with one exception, and that is Sierra. Sierra never stopped improving the technology, knowing that wet sensor drift problems must be solved. After all, by its very principle of operation, a thermal sensor is heated and cooled over time, expanding and contracting the cement inside the sensor, making it crack, settle, and shift from its original state. Dr. Olin believed there had to be a better way. He needed to get rid of all cements to make the most stable thermal sensor in the world. After many years of experiments and testing, the answer finally revealed itself. On March 9, 1999, Dr. Olin patented a breakthrough thermal sensor design. Like other thermal mass flow sensors, it was made of a platinum resistance temperature detector wire wound around a ceramic mandrel. But this is where the similarities ended. Through a proprietary, highly controlled manufacturing process, a metal sheath is tightly formed on the mandrel and wire assembly to be in such intimate contact that no air gaps exist and no organic filler cements are needed. This new sensor was literally all metal. In contrast to wet sensor design, this innovative cement-free sensor is known as a dry sensor. It is patented by Sierra and is brand named DrySense. Because the all-metal DrySense sensor is so rugged, reliable, and stable, Sierra has backed quality claims to be the only company in the industry to offer a lifetime warranty on their thermal sensor. With wet sensor versus dry sensor design in mind, let's briefly discuss in situ calibration validation. Quality systems like ISO 9000 may require annual or even semi-annual calibration and validation of all measurement instruments in a facility. One of the nice features of thermal mass flow meters is that the calibration can be easily validated in the field at a very low cost. In situ or field calibration validation of thermal meters is a highly marketed feature because it saves money on calibration and downtime. Sierra customers have enjoyed this advantage for many years. Sierra's motto has always been, don't recalibrate, validate. But be careful, there is a lot more going on behind this statement than you may first think. There is a lot of smoke and mirrors by thermal manufacturers about in situ calibration. All thermometer manufacturers have generally the same method of in situ calibration validation to confirm the original factory calibration while checking for drift and assuring accuracy. The basic process makes use of the electrical characteristics of the sensor, either by checking that the electrical resistance of the velocity sensor's platinum resistance temperature detector wire has not changed over time, or by assuring that the power sent to the velocity sensor at zero flow is the same as when it was first calibrated at the factory. The problem with both methods is that they only measure the characteristics of the internal sensor windings and do not address sensor drift. The big question is, how can you validate a sensor that will drift out of spec due to the very nature of its mechanical design? The resistance of the platinum wire shouldn't change, and the current running through the sensor might be the same, both of which would validate OK. This is a false positive, as the drift inherent in a wet sensor design would remain unseen. Sierra's DrySense all-metal no-drift sensor has a big advantage during in situ calibration validation. With Sierra's all-metal DrySense velocity sensor, you have the mechanical design confidence that there will be no drift and that in situ calibration validation is indeed actually valid. Sierra offers a free in situ calibration validation software package we call ValidCal Diagnostics. Unlike some other validation routines, Sierra's ValidCal Diagnostics program provides a complete check of all the meter's components, including the velocity and temperature sensors, sensor drive circuitry, accuracy of the pressure transducer, and all digital and analog outputs and alarm relays. When complete, a detailed calibration certificate and diagnostics report is created. All of this can be accomplished without even removing the meter from the process piping. For accurate and repeatable gas mass flow measurement down to the last molecule, choose thermal mass flow technology. Experience our passion for flow. For more information, go to
Again, a very powerful video that you can share with customers, potential customers, etc., of supporting your efforts of selling the Q-Therm. And again, this is any of our no drift sensors from the 640S, 780S, up to the Quadratherm. Here's a good 5-point argument that you can use when you get into this discussion. Flow meter is a means to transfer calibration to the field. We talk about our flow loop, DrySense technology, no organics or epoxies. It's going to be very, very stable over a long period of time. You can prove this by using the validation routine in the SIP. And again, we'll replace the sensor for free and a lifetime in the instrument if it fails this validation. So again, said before, we've had a lot of them damaged, but none of them have actually had a sensor fail. So very, very powerful. Markets. A lot of times when I'm out on the road or we're having discussions of, well, where do we sell these? Well, any place where there's gas flowing, you have an opportunity to sell a flow meter. It's up to you to convince them that they need a flow meter. And in a lot of places, they're not going to pay the money to sell that flow meter. But anywhere where you see gas flowing or where there's gas flowing, there's a potential to sell a flow meter. Different locations there. We've just kind of did a quick little breakout of where a lot of these are sold. You see air is a big one, methane is a big one. Flare has been growing exponentially ever since the oil and gas boom here in the United States over the last number of years. And then biogas is gaining a lot of attention going forward. Okay. So we're going to take a little bit of time here to cover a lot of the things that we have talked about and put it into practical use in terms of how to size a Sierra thermal flow meter, and then how that would work on a couple applications in terms of what we might possibly sell. So get your pencils and papers and calculators ready, because we're going to have a little bit of fun here, okay? So each thermal meter has a maximum standard feet per minute it can be calibrated to. We went through there, I showed you all those things in the different the gas table list. Some of them have different maximums for different gases, and the price book has the maximums for all of the gases. So for example, 30,000 standard feet per minute maximum for any gas or gas mixture. 640S, 20,000 standard feet per minute for air. 16,000 maximum for methane. Boiler track, 12,000 standard feet per minute maximum for methane. So how do we do this? When you have a customer come to you, you have an application, where do we start? Well, the best place to start is you need to know the pipe size. And you need to convert that to square feet. You can find the area of the pipe in the gas table. So if pi r squared is not handy for you, we've done it for you right here. All the different areas for the different size pipes. Okay. Standard feet per minute times the area of the pipe in square feet is SCFM. Okay. So let's do the math. Boiler track, methane, 4-inch. What is the maximum flow at standard accuracy? I'm looking for a complete and correct answer in the chat box. And complete and correct answer means proper unit of measure. And the proper unit of measure here will be standard cubic feet per minute. First answer, close but no cigar. And to help everybody, the area of the pipe that I'm using is based off of our gas table. All right, so we don't get into arguments of, well, my pi r squared equals this and my pi r squared equals that. Little high on that flow rate. Give a couple more tries here. Whoa. Jason Bowers nailed it. A close second was Dan Morley, and a close third was the crew from Omicron. The answer is 1,060.8 SCFM. All right, Maria Dean, $20 to Jason Bowers, Starbucks.
All right.
Got it? Okay. So we now have an answer of 1,060.8. Okay, the minimum calibrated full scale we can do for any thermal is 0 to 500. So if you did the math there, you find out what the minimum flow rate. And remember, any serial thermal can measure zero flow. So if in this particular application, the customer said, well, I think my flow rate is 800 SCFM. Perfect. All right, perfect, no problem. We are going to calibrate it 0 to 800. If the customer says, no, I think my flow rate is 10,000 SCFM, well, the first thing you're going to probably tell them is, well, I think that's physically impossible, but maybe there's something else to it. Like, for example, his methane flow is at 1,000 PSI. Now that might be possible, but we're not going to measure it with a 620S boiler track. So as you come up with these answers, it helps validate the application, and it validates that you have the proper meter, or it opens up all kinds of other questions about, do I have the right product for this application? Let's do it again. 640i, air application, 10-inch pipe. Use the area off of the gas tables. What's the maximum flow with standard accuracy? Looking for it in the chat. Proper answer, and the unit of measure will be standard cubic feet per minute. We'll give it about a minute here to see if someone can come up with the answer. There's an answer. Matt Tijon, the winner. Very nice, Matt. Way to go. Mary Dean, $20 to Matt. Okay. The answer is 16,440 SCFM. The minimum calibrated full scale we do for any thermal, again, is 0 to 500. So you could calculate what the minimum is. And remember, we can measure it to 0 flow. Now, to help out those that are saying, there's no way in heck that's the right answer, let's look at this to show us how we got to some of these answers. If you remember, here was the accuracy statement on the first question. Here's how we got to the accuracy statement. So question 1, boiler track maximum flow is 12,000 standard feet per minute times the area in square feet equals 1,060/80. And the question that we just did, 30,000 standard feet per minute. That's the maximum full scale for a 640i times the area of the pipe in square feet gives you 16,440. So nice job. I've seen a lot of other correct answers as well, so I appreciate the participation there. Got just one more to go. All right. So now we're going to do a pop quiz or two. 4-inch pipe air, 640S. Remember, at 640S, customer wants 500 standard cubic feet per hour. So what's the maximum flow at standard accuracy? What's the minimum flow? Maximum flow for air on a 640S would be what? What's the minimum flow? I need those two answers in the chat room when you can do it. And note, the proper answer will be in standard cubic feet per hour. Standard cubic feet per hour. So there's an extra step I threw in there. Blair has the right full scale, but in the wrong unit of measure. Darren and Mary Dean help watch it as well. I got Ryan Wellman as the winner. Nice job, Ryan, and the Omicron team. Jim Hampson, you were so close. You had the top. I'm sure you were working on the bottom flow. So the answer is 106,080, 2652 on the low end. How in the world did we come up with that? Right here. 640S, 20,000, area of the pipe. That's your SCFM times 60 gives you in per hour. Mary Dean, 20, oh no, this is a dual one, $40 going to Ryan Wellman
Got it.
in coffee. He can share that with his whole crew there. Minimum flow, 500 times the area of the pipe, 42.2 SCFM, 60 gives us this. All right, okay, great. We have that information, but let's go back up to the original question. The customer came to you saying, I've got air and I want to measure 500 standard cubic feet per hour. Is it even possible? Well, we can do it, but what do we have to do? The minimum full scale on a 640S is what? It's 500. So the full scale, the minimum full scale would have to be this. He wants to measure this. What's the accuracy? This is a 1% plus 0.5% of full scale device. He's going to have a big uncertainty right here. Okay. Customer may be okay with that. And he says, that's great. I'll go with it. Customer might say, no, that I can't live with that. I need to be able to measure to 400, 200, 100. So what would you do in this type of situation? You would sell him a 640i with the ULF calibration. So that way you could actually calculate what the standard feet per minute here is. It's probably like 200 standard feet per minute, because if this is 500, well, it might be a lot less than that. It might be 100 or 120 or something like that. Not a problem. You can quote him a 640i with a ULF calibration, calibrated 0 to 500. He's going to be able to measure all the way to zero flow with standard accuracy and do those calculations that we did before. All right, last one. This is for all of our flare gas applications that we deal with every day. 8-inch pipe, methane, 640i. Customer wants 20 million standard cubic feet. That should be per day, folks. We missed that. This is per day. Standard cubic feet per day, not per hour, per day. What's the maximum flow at standard accuracy? Unit of measure will be standard cubic feet per day that I'm looking for. Okay, just remember, we're looking for 20 million standard cubic feet per day. That's what the customer wants. Standard cubic feet per day. And Ryan Wellman nails it again. Beautiful. 20 bucks to Ryan Wellman, Mary Dean. So here's the answer. Answer, 10,410 SCFM, 62,500, which is an error. This should be 64,600. And 14,990,400 standard cubic feet per day. How in the world did we figure that out? Is right here. 640i, standard accuracy, 30,000. There's your square feet. There's your SCFM. Times 60 to get to hour is 624,600 times 24 standard cubic feet per day. Okay. All right. Well, the customer wanted 20 million. Okay. Oh, it's actually correct unit of measure here. So this falls within the 2x field change if already in the field, but there will be a derate. If you remember, we talked about that's one of the powerful abilities of the 640i. You can increase the full scale flow rate. So if we wanted to, this is a very, very small increase. So you can easily increase the full scale to 20 million in the field. I'd call it, we probably go to 1, maybe 2% of full scale accuracy, but they're not pulling it out of the line. They don't have to shut down anything. They're up and running. Okay. If this is a brand new meter and it's calibrated to 20 million, it will have a D rate, 2% of calibrated full scale. Because if you remember, we go back to the price list, we do have that option. 30,000 to 45,000 standard feet per minute gives you 2% of full scale. So they could have it calibrated that way to start with. Or they could possibly change the pipe size to 10-inch and have standard accuracy at 20 million. So again, we're going through this process to find minimum and maximum flow rates, comparing them with what the customer wants to see what's going to work and what might have to change. And I appreciate all those that were kind of playing along on the home game, coming up with these various different answers. It's good to see. Thermal flow meter competitive matrix. This is really, really busy. You need to get your magnifying glass out for this, but it stacks us up against our own product, the Fox product, the FCI product, ENH, Magnetrol. You can see all the different specs there, but just keep in mind, everybody's product on there is drifting like a boat in the ocean. So if you want long-term stability and performance, you're going with a Sierra. There's a couple of the other competitors as well. Same thing here. Okay, website, we've been there a couple times. It's a tremendous resource that you can go to, and keep in mind, the website is where all of these great RFQs come from. And a lot of you have noticed we've started up this new program with HubSpot, and HubSpot is a tracking tool for those RFQs. And I know so many of you, it's the first thing you do when you see the RFQ. You're getting a hold of it, you're calling the customer, you're quoting. You guys do a tremendous job, and you have tremendous high close rates, some 30, 40%. Show the rest of the world how strong you are, because that HubSpot tracks that. And if you've noticed, we've started sending out monthly reports, and there are a lot of eyeballs watching those monthly reports because we spend a lot of money trying to generate those RFQs for you. So show the rest of the world your performance, your 30% close rate, your 100% contact rate. So take your time, make sure that you understand HubSpot, how to move around your different leads, and take credit for all your wonderful work. If you have any issues or problems with that, Mary Dean is available for any kind of help, tutorial, whatever, to make sure that what you're accomplishing in the field is seen by everybody, not only within Sierra, but within the entire Tazi Flow world. So take that little extra bit of time and make sure you're following along and updating HubSpot. Okay, again, web source resources, everything that you would possibly need for our products is on the website. So go there, and then that wraps it up. So questions, I know there was 1,000 questions. It looks like my chat box is, I don't know, half-mile long, which is great to see. But I'm here all day, so we can have whatever questions we want on the webinar. But again, I thank everybody behind the scenes at Sierra, from Marriott Dean and Evan and Josh and Erica and Darren and Phil and Scott and Dave Hundley and everybody that was there that made this a possibility. We're so honored to be able to present it to you. And like I said, there's still a lot of our products left. We got ultrasonic, we got Vortex, we got Switch, we got all our scientific, and the goal is to come out with something similar for all of those. So good luck, and keep selling that product. So it's opened up to questions to everybody and anybody. So it doesn't have to go through chat. You just raise your hand if you want to, or you can ask questions via your local Sierra contacts as well. So
Glenn, we've got a question here wanting to know if all instruments come with a CalCert.
all thermal flow meters come with a NIST traceable CalCert. All Vortex meters do. All Sierra Scientific do. There's options on the ultrasonic that are called out in the price list.
Okay. Well, thank you everybody for joining us, and have a good afternoon or evening and morning.
Evening, morning, late afternoon. Thanks for everybody that joined us from across the whole globe. That's exciting. So.
All right. Bye-bye, everybody.